Before we can explain physics, we need to know what physics is. Physics is our view of the universe, part of our search for meaning. Mathematics is a guide to our search for meaning, the language of everything. Newton used this theory to explain the orbits of the planets. It gives quite consistent results. But when it comes to the orbit of Mercury, deviations occur in calculations. Normally, planets must arrive where they started after completing one full turn around the Sun. But when Mercury's orbit is observed, this planet does not come to where it started after its one full turn. A very small amount was advancing. This deviation would in fact show that Newton was wrong in gravity. We can think of the gravitational force like a rope. Gravitational reacts to change suddenly. If the Sun disappears in our solar system, the planets will suddenly come out of their orbit. However, as we know from Maxwell's electromagnetic equations and the previous states, the speed of light is a limit, and approximately 300,000 km per second. This means that the planets must come out of their orbit at a certain time, not suddenly. Albert Einstein enters the scene here. It reveals the general relativity. According to general relativity, these orbits are actually twists in space-time. If the Sun disappears in general relativity, the planets will be out of their orbits in a certain time. You will probably say, how can we prove this twist? How do we know that keep us in orbit is the twist in space? The two stars you see on the screen are a type of stars called quasar. These two stars are 14 billion light years away from the Earth. They called one of these two stars 957 and the other 561. As a result of the examinations, these objects were very similar to each other, too much, and these objects were actually the same. It was a single object. This optical illusion was created by objects in space-time bending light. This illusion is proof of general relativity. So, if we can bend the light, can the pit created by massive objects in space-time trap light? Yeah. Black holes. It will be much better for us to learn how they were formed before we described black holes. Black holes are formed when the atoms of massive stars collapse into each other and their atoms pass into each other. The collapse in them occurs follows like that. The mass of millions of billions of trillions of tons of hot plasma are being pulled inwards by gravity and squeeze material together with so much force that nuclei fuse. Hydrogen fuses into helium, This releases energy which push against gravity and tries to escape. As long as this balance exists, stars are pretty stable. Eventually, the hydrogen will be exhausted. For a moment, the balance of pressure and radiation tips and gravity wins, squeezing the star tighter than before. The core burns hotter and faster, while the outer layers of the star swell by hundreds of times, fusing heavier and heavier elements. Carbon burns to neon in centuries, neon to oxygen in a year, oxygen to silicon in months, and silicon to iron in a day. And then, death. Iron is a nuclear ash. It has no energy to give and cannot be fused. The fusion suddenly stops and the balance ends. Without the outward pressure from the fusion, the core is crushed by enormous weight of the stars above it. Particles like electrons and protons really don't want to be near each other, but the pressure of the collapsing star is so great that electrons and protons fuse into neutrons, which then get squeezed together as tightly as an atomic nuclei. But not just the core, the whole star implodes, gravity pulling the out layers in at 25% the speed of light. These implosions bounce off the iron core, producing a shock wave that explodes outwards and catapults the rest of the star into space. This is what we call supernova explosions, and it will outshine entire galaxies. What remains of the star is now a neutron star. And if it were any denser, it will become black hole. These objects are so dense and massive that they form a place called singularity. We don't know exactly what's happening in this place, but we know they are great. Of course, as everybody has an end, it hasn't end. How does it end? We learn the answer of the question with Stephen Hawking. Black holes explode and disappear. Let's imagine a medium-sized black hole in space. Around it, positive and negative virtual particles collide with each other in 1 billionth of a second and exist again. If these virtual particles occur near the event of horizon of the black hole, the negative particle is drawn in, while the positive particle becomes a real particle rather than a vertical particle, and creates a radiation around the black hole. The negative particle reduces the mass of black hole. Radiation is producing more slowly in large black holes. In small black holes, radiation is producing at incredible speed, so black hole disappears. We know that the beginning of our universe is with the Big Bang. So, how do we know that the beginning of our universe was the Big Bang? With Doppler effect. When an ambulance passes by us or a fast-moving vehicle presses the horn, you will first feel a slight frequency, and then the frequency will increase when the object approaches you, and the frequency will decrease gradually when it moves away from your current position.
Bu Doppler.
Like that, we observe the same in light, but in color. The higher frequency, the more blue shifts. The lower frequency, the more red shifts. When we integrate this into space, the nearby galaxies will look blue, while the distant ones are red. Edwin Hubble would prove that the universe is expanding. Actually, before Edwin Hubble, there were people who knew how important galaxies shifted to red, but Hubble was the one who proved by presenting a data. According to these data, there was a proportion of the galaxies redshifting and increasing. The further galaxy, the faster shifting red. This indicates that the universe is expanding. If the universe is expanding, it must have gathered at some point in the early days of the universe. The time when this point expands is called the Big Bang. Bu projeye sığmayan o kadar çok şey var ki. Sicim teorisi, çift yarık deneyi, Schrödinger'in kedisi, termodinamik, atomik model, özel görecelilik, elektromanyetizma, kuantum mekaniği ve birçoğu. Hepsi hayata bakışımızı kökten değiştirdi. Bunlar üzerine çalışma yapan bilim adamları ise insanlığa büyük katkıları bulundu. Bir yandan ise bilimi popüler yapan Evrim Ağacı gibi siteler veya kanallar, topluma bilimi yayarak, sevdirerek toplumun daha gelişmesini sağlıyorlar. Bu gezegene en ufak katkısı olan herkese teşekkürler.